Hello and welcome to week 4 in chapters 6 and 7. Please note that there will be a quiz available for you on D2L all day Friday that is going to cover some of the main concepts of weeks 1 to 3. The topics and concepts that are going to be on this exam will be posted on D2L by Wednesday night of this week, so please make sure that you are checking D2L for this so that you know what to study for this quiz. This quiz is designed to help you remember and refresh some of the main concepts that we've recently discussed so that when you go into the exam that's going to be over weeks 1 through 4, that will be this following week, you have a strong memory of those concepts so that it'll be easier when you actually take the test. Now in this chapter we are looking at what happens when we apply heat to foods. There are a few different methods of cooking that we will talk about, and we will also review how heat is transferred. We'll actually look at the mediums of heat transfer in cooking. So again, for this chapter we're looking at the mediums of heat transfer and the different types and different ways that we can transfer heat to foods. So, be able to explain the characteristics that differentiate convection, conduction, radiation, and microwave cooking from one another. Understand how heat transfer works in cooking and learn when oil, water, and air are effective mediums for heat transfer. Discern the characteristics and types of dry heat and moist heat cooking methods from one another and be able to explain when it is beneficial to use microwave cooking and when it is not. This slide looks at the three main ways that heat is transferred, and these three ways are conduction, convection, and radiation. While these are all three very different forms of heat transfer, understand that a person heating a food, believe it or not, may actually be using two or even all three of these forms of heat transfer. Conduction involves transmitting heat through direct contact. This means that the item being heated must directly touch the heat source. Convection sounds similar and actually is a little bit more similar because it is more so related to direct contact, but the heat transfer that occurs is more so through the movement of warm gases or warmed liquids. In convection cooking, gas or liquid molecules are heated, and the heat that is provided to each of these causes the molecules to move. As these molecules are moving, they come into contact with other molecules and heat these molecules. So when you're heating water, you warm the bottom of the pan. This warmth at the bottom is going to heat the water molecules near the bottom. These molecules will move towards the top, which is going to cause other water molecules to heat up as well and also move through the pot and move towards the top. This movement and the heating that occurs through this movement is convection heating. In radiation heating, there is no direct contact and no help from air or water. Rays are directly transmitted from the source of the heat to the item that's being heated. The goal of this slide is to reinforce what you went over on the previous slide. So let's go ahead and review some of these major concepts. We're going to look at visuals of how conduction, convection, and radiation works. So first of all, we have conduction. Now what we have here, we have a warm pot. So let's call that pot, but because the pot itself is warm, it is actually a source of heat. Now because that handle is coming into direct contact with that pot, that handle is being heated by that pot, and that heating is conduction, direct contact. If the person were to lower this pot into the fire so that it was actually touching either the coals or the wood that was burning, so that it was directly in contact with the heat source, that would be another form of conduction. Convection explains what is going on in the boiling water. There are very warm water molecules that are circulated throughout the water. The heating of water molecules causes their circulation. So the water molecules on the very bottom are heated, and then they rise to the top. As they rise to the top, that's going to bump into other water molecules and transfer that heat that was produced at the bottom of the pot to the other water molecules, and these water molecules will follow suit and do the same thing. So they'll move to the top of the boiling water as well. Overall, they're all going to circulate throughout the pot, bump into each other, and as they continue to bump into each other, they're all going to warm each other up and create more energy. And overall, that is how convection cooking will continue to work. The third method that we see is radiation. And this occurs not from an actual medium, such as water or oil, but just through air. So you can see there's no direct contact that's going on with the fire and the pot, but somehow that pot is still being warmed. And this is through the movement of waves, very high frequency, high energy waves, to the pot. And you can feel it. If you stand around a fire, you will feel the warmth of the fire around your legs. This warmth is occurring from the radiation that is being sent off from the fire towards your legs. To get heat to go from one source to a food or to another source is going to require a certain heat medium. The medium sends heat from the heat source to the food. These different mediums transfer heat differently to various foods, but each medium does have a different purpose. There are two forms of heat transfer, and these include dry heat and moist heat. Dry heat involves no water. This includes air, and because oil and fats do not contain any water, oil is also considered a method of dry heat as well. Moist heat involves heat transfer through water in any way, shape, or form. Keep the gas form in mind as we move on to the next slide. All forms of moist heat cooking involve some type of liquid. Boiling is an obvious example of moist heat because you're placing food directly into water. But what about steaming and stewing? Steaming does involve the transfer of water, but it is through the gas form. Water is boiled and then steam rises above it to heat the food. This is still just water, but just in a different form. Some stews may not actually cook with water, but they may use a broth, and also the juices that come out of the foods in the stew are going to contribute to liquids that it is cooked in. Although oil is in a liquid form, it does not contain any water and therefore is considered a form of dry heat. Anytime you are heating with oil, this is a method of dry heating. Also, when foods are heated through radiation, as is the case with baking, roasting, and grilling, the medium used for heating is air. And no water is actually going to be heated during this process, unless it's extremely humid out, but let's not get too complicated with this. So to review, what type of cooking occurs when you cook vegetables using both oil and the juice from the vegetable? I am honestly not entirely sure, but I know that if it is just the juice, it is moist heat, and if it is just the oil, it is dry heat. And that's the main concept that you should understand for this slide. Moving back to heat mediums, there are 4 ways that heat can be transferred to food. Unless you place a food directly on a heating surface, which is possible but not ideal, go ahead and crack an egg directly on a pan or on a stove top without any oil. This egg will be edible, sort of. There will be a lot of dried material that has to be scraped off that you do not want to eat, making the cooking process more difficult and reducing the edible portion of that food. The purpose of a heat medium is to make heat transfer effective, so that when we cook the food, we create the most optimal taste and get the most out of that food product. Air and oil are both forms of dry heat. Water is moist, and since steam is a form of water, it is also moist heat. Microwave cooking is a form of radiation heating, but it is different from radiation heating that occurs through a process like grilling or baking. The microwave machine transmits heat waves called microwaves to food to produce heat. These waves are very direct and have a very short wavelength. When you go out to the pond near the baseball field and the 2-mile path on our campus on a day with very light or no wind, you may see very light ripples in the water. Now, if you go out to Lake Charleston, a much larger lake, during a period of high wind, such as a tornado, there is a chance that you will see very large waves in the water. In terms of heating, the microwave waves are very subtle and more like the ripples on our pond. These waves are either transmitted, absorbed, or reflected. Transmitted means that they are sent out from a source. Absorbed means that a food object will pick them up and use them. And reflection occurs when they bounce off the walls in the microwave, things that will actually not absorb the heat of the microwave waves themselves. These waves hit food and directly act on molecules in the food that are polarized, and most of the molecules in the food are polarized. Polarized mean that there is a slightly imbalanced electrical charge. You do not have to know too much about the science of this, but what it means is that these molecules are not stable with one another. Polarized molecules are not stable with one another and will not want to be too close to each other for too long. They simply don't attract perfectly with one another, and therefore they have relatively weak connections. Either way, there is a slight electrical charge on each end of the molecule, so that we'll have slight attractions to other molecules that also have a charge. In this way, opposites attract, but these connections, they do not stick permanently, because that original molecule, the polar molecule, is going to remain intact. These molecules are going to move around, and microwaves will cause this movement to occur very rapidly. The movement that occurs from this generates heat, and the heat is spread throughout the food. You do not have to know this specific mechanism for how this works. You do not have to know what the polarized molecules are, but you should have a more basic idea and be able to differentiate the main concepts of microwave cooking from the other 3 types. So it is through radiation, very high frequency electromagnetic waves, and these waves, they can be absorbed, transmitted, or reflected. Microwave heating has many benefits, and these are largely related to convenience and speed. The cooking and reheating of food can occur at a very rapid rate, and with minimal attention, the heat is distributed very evenly throughout the food. Potentially due to the low amount of time that foods are cooked in microwaves, the nutrient loss from microwave cooking is significantly less than nutrient losses from other forms of cooking. Vitamins and antioxidants are destroyed at much lower rates when they are microwaved compared to when they are heated through other methods. At the same time, there are some limitations to microwave cooking. There is no browning that occurs from the microwave that you will get from other forms of heating. This browning creates an optimal flavor and texture that can actually be essential to certain dishes. Browning does not occur in the microwave units because the microwave environment itself is very cool. There are very few, if any, polarized molecules inside of a microwave oven outside of the food. The insides of the food are warm, but the outside temperature is normal, and so the external surfaces are not significantly heated or cooked. Also, cooking food for a longer period of time can create optimal texture and tenderness that cannot be replicated in the microwave. And finally, because heating occurs so quickly, it is very easy to overcook microwave foods.